In this screencast, we are going to cover a pre-algebra construct that will play a very important role in your ability to simplify algebraic expressions, and that is the order of operations. What would happen if ABC Driving School taught their students that red meant stop and green meant go for the traffic lights, and XYZ Driving School taught the opposite? Obviously, it would create accidents. The order of operations is essentially a traffic guide for us that all of us must agree to. For example, if one group of engineers was working on the guidance system for an airplane and they used one order of operations, and another group of engineers used a different order of operations while working on the same guidance system for the airplane, that could produce catastrophic results during the first flight. So we'll go through the order of operations, but we'll start with an assessment here to see how well you already know the order of operation. Simplify each of these numeric expressions without a calculator. It's worth pausing the video right here and actually doing this. Now that you've done the computation, if you got 225 for this right here, or if you got 0 for this expression right here, then you're probably taking the acronym PEMDAS too literally. If you've never heard of PEMDAS, please ignore this, but most people have heard of it, and it can be misleading to some students. We are going to go through the order of operations without the acronym PEMDAS and do some practice as well. For those of you who have heard the acronym PEMDAS, usually the P stands for parentheses, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. And as was mentioned in the previous slide, this can be misleading for some students. For example, even though the A comes before the S, addition is not given precedence over subtraction in the order of operations, yet it looks like the A comes before the S in the acronym. Another way it can be misleading is this P. When parentheses are used as an operation, that's specifically the operation of multiplication, but that's not what's meant here. What's meant by this is if there is an operation set off inside of parentheses, then you need to do that first. So this is a misleading acronym for many. So instead, we are going to simplify the order of operations a bit and get some practice with it while ignoring this PEMDAS acronym. There are 3 tiers to the order of operations. First thing that must be done is exponentiation. Second thing that must be done is multiplication and division. They're on the same tier, and you do them in general from left to right in whatever order they show up. So you don't just do the multiplication first. You do whatever shows up from left to right in the expression. The third and final tier of the order of operations contains addition and subtraction. So you do them last amongst all of these operations, and between those two, you do them from left to right in whatever order they show up in the expression. However, there is one caveat to this order of operations here, and that is if somebody, for example, wanted you to do multiplication before exponentiation, what would need to be done is you would need to put that operation within parentheses, all right? Anytime there's an operation within parentheses, that must be completed before all else. So there are 3 tiers to the order of operations, but if someone wants you to ignore the order of operations and do a lower tier before a higher tier, then they would put that operation within parentheses in the expression, and that would tell you that you should do that computation first. So now let's use the order of operations to simplify each of these numeric expressions. Over here, we've got 2 operations. The operations are multiplication and exponentiation. First, realize that the parentheses themselves, when you put them up against each other, that means you're multiplying these 2 things. That's why I've just put that dot in there. There are no operations within the parentheses. Within this set of parentheses, there's just the number 3, and within this set of parentheses, there's just the number 5. So someone is not trying to tell us to do a particular lower operation first. Instead, it's just multiplication and exponentiation. And of those 2, exponentiation is higher order than multiplication. So we've got to do the exponentiation first. We've got 3 times the 5 squared is 25. And then finally, we do the multiplication, and we get 3 times 25 is 75. For any of you that may have gotten to 25, ultimately, you did the 3 times 5 first, giving you 15, and then 15 squared is 225. But again, there is no operation inside of the parentheses. In this case, parentheses are being used to represent multiplication. For this problem, the operations are subtraction and addition. And addition and subtraction are on the same tier with each other. So you don't simply do the addition first. In general, you do them from left to right, whichever order they show up in the expression. So since the subtraction shows up first, we do that before the addition. 7 minus 3 is 4. 4 plus 4 then is 8. If you'd gotten 0, you probably took the 3 and added 4 and got 7, and then 7 minus 7 is 0. Again, addition does not come before subtraction. They're on the same tier. You do them from left to right in whichever order they show up in the expression. Let's take a look at some more complicated expressions. Here we want to simplify each of these numeric expressions, again without a calculator, using our knowledge of the order of operations. In this particular one, we've got two operations here. We've got subtraction and we've got exponentiation. According to our agreed upon order of operations, exponentiation occurs before subtraction. However, in this particular case, someone is trying to tell me that they want me to do the subtraction first because the subtraction of 10 and 3 is set off inside of parentheses. So we must do that first. We've got the 10 minus 3 is 7, and then we square that result of 7, giving us 49. Let's take a look at this one. Here again, we've got subtraction and exponentiation. But in this case, they are not asking us to do the subtraction first. There is no set of parentheses around the 10 minus 3. So of these two operations, the exponentiation comes first. So we've got 10 minus, and then 3 squared is 9. Make sure you also realize that this is not a negative sign. This is a subtraction. It's an operation between the 10 and this thing. So we've got the square of 3 is 9, and then we do the 10 minus 9, giving us 1. So a very big difference. These are fairly similar in the way they look, but this one's representing 49, this one represents the number 1. Let's take a look at this one here. In this case, we've got three operations. We've got addition, there's multiplication here between the 2 and that expression in the parentheses, and we've got subtraction. Technically, multiplication would occur before both addition and subtraction, but again, someone is trying to tell me to do the subtraction first. That's why the 3 minus 4 is put in parentheses. So I'm going to write everything else down the same, 5 plus 2 times, and then I'm going to actually just do the 3 minus 4 and get negative 1. Then of the two operations that are left, addition and multiplication, now the multiplication is done first because it's higher order than the addition in the order of operations. So you've got 5 plus 2 times negative 1 is negative 2, and then 5 plus negative 2 is 3. So this expression is the number 3. And then finally, we have this expression here that we want to clean up. Real quick, make sure you note that there's an implied set of parentheses around the numerator and denominator of fractions and around the radicand of a square root. So this is not a square root, but it is a fraction. So there's an implied set of parentheses here and an implied set of parentheses here. People just don't write them. What that ultimately means is to simplify the top and the bottom separately. Then your final result could be a fraction, or if you wanted to convert it to a decimal, then you would do this division at the very end. Let's do this. So up here, we've got two operations in the numerator. You've got subtraction and you've got exponentiation. This is not a subtraction symbol because it's not between two things. This is a negative sign on the 3. So we've got negative 3 minus the square of 1. Before the subtraction, we have to do the squaring based on the order of operations. So we've got negative 3 minus the square of 1 is simply 1. Now we haven't fully simplified the numerator, but we'll do that in the next step. Let's now take a look at the denominator. So we've got division and addition, and typically division comes before addition. However, this is specifically saying that they want me to do the addition first. So we're going to do the 5 plus 1, and we get 6. So we got 24 divided by 6 in the denominator, and now we'll do each of these computations that are left. Negative 3 minus 1 is negative 4. 24 divided by 6 is 4, and you would never want to leave a fraction that could possibly be reduced, and negative 4 divided by 4 is simply just negative 1. So this messy expression simplifies to negative 1, or it's equivalent to that. This expression is equivalent to 3, this expression is equivalent to 1, and this expression is equivalent to 49. In general, in mathematics, we always want to be able to write expressions in simplest form. We are going to continue with this in a coming screencast. This screencast was meant to remind you of the order of operations or to potentially correct your understanding of the order of operations.